Dear students, let us start the problems. The problem number 9. The resistivity of copper is 1.7 into 10 raised to negative 8 Newton meter. Find the length of copper wire of radius R is equal to 1 millimeter having a resistance 1 ohm. We know the expression for the resistivity rho is equal to R into pi R square by L. From that, L is equal to R into pi R square by rho. We are given rho is equal to 1.7 into 10 raised to negative 8 ohm meter, and the radius R is equal to 1 millimeter, that is equal to 1 into 10 raised to negative 3 meter. And the resistance R is equal to 1 ohm. Let us substitute all the values of R, small r, and the resistivity. That is 1 ohm into 3.14 into radius 10 raised to negative 3 square divided by the resistivity 1.7 into 10 raised to negative 8. After the calculation, you will get 1.847 into 10 raised to, that is 184.7 meter. Now this is the length of the copper wire. The next one, find the resistance of a wire of length 1.5 meter and a diameter 0.2 millimeter if the conductivity of the material of the wire is 6.25 into 10 raised to 7 per ohm per meter. Here we have to find the resistance. We know the expression for the resistance R is equal to rho into L by A. Here A is the pi R square. And instead of resistivity, we have the value of conductivity. So R is equal to L divided by 1 by rho is the 1 by sigma is the resistivity. The reciprocal of conductivity is the resistivity. So that is 1 by sigma by R square. Now let us see what are the values given. Here we have L is equal to 1.5 meter. L is equal to 1.5 meter, and the conductivity sigma is equal to 6.25 into 10 raised to 7 per ohm per meter, and we have given the diameter. So the radius R is equal to the half of the diameter, that is equal to 0.1 mm, that is equal to 1 into 10 raised to negative 4 meter. Now we have all the values. Let us substitute. Therefore, R is equal to length 1.5 divided by pi 3.14, radius 10 raised to negative 4 whole square, the value of sigma, that is 6.25 into 10 raised to 7. So you can complete the calculation. After the calculation, you will get the value of resistance is equal to 0.762. 0.762 ohm. Now the next one. Calculate the length of a constant wire of radius 0.1 mm to get a resistance of 10 ohm if the resistivity of the constant is 49 into 10 raised to negative 8 ohm meter. Here we have to find the length of the constant wire. So we have the expression for the length. L is equal to R pi r square divided by the resistivity. Now what are the values are given? We are given capital R is equal to 10 ohm, and the smaller, the radius of the copper wire, constant wire is equal to 0.1 mm, that is equal to 1 into 10 raised to negative 4 meter, and the resistivity of the constant wire is equal to 49 into 10 raised to negative 8 ohm meter. Now let us substitute. Therefore, L is equal to 10 ohm into 3.14 into 10 raised to negative 4 whole square, that is the radius, divided by 49 into 10 raised to negative 8. So after the calculation, you can have the value of the length of the constant wire is equal to 0.64 meter. The next, calculate the length of a manganese wire of diameter 0.315 millimeter required to make a 20 ohm resistance. The resistivity of manganese wire is 44.5 into 10 raised to negative 8 ohm meter. Here also, we are asked to find the length of the manganese wire. So, let us write the expression for the length. L is equal to capital R into pi small r square divided by the rho. Now we are given the resistance R is equal to 20 ohm. Instead of radius, we are given the diameter. So radius is equal to small r is equal to d by 2, that is 0.315 by 2 millimeter, that is equal to 0.1575 millimeter, that I can write into meter, we can convert into meter. So let us write 1.575 into 10 raised to negative 4 meter. And the resistivity rho is equal to 44.5 into 10 raised to negative 8 ohm meter. Now let us substitute. That is L is equal to radial resistance 20 ohm, 3.14, radius square, that is 1.575 into 10 raised to negative 4 whole square divided by the resistivity, that is 44.5 into 10 raised to negative 8. So you can complete the calculation. The answer will be the length of the manganese wire is equal to 3.5 meter. 3.5 meter. Next, the resistance of a wire is capital R if it is stretched to 3 times the original length. What is its new resistance? The resistance of a wire is capital R if it is stretched to 3 times the original length. What is its new resistance? Here we have to keep in mind that when the length is increased to 3 times without a change in volume, then the area of cross section is reduced to 1/3 of its original value. That is, if we are increasing the length without any change in volume, then the area of cross section is reduced to the same proportion of the, that is in which the length is increased. Here the length is increased to 3 times. So correspondingly the area of cross section is reduced to 1/3 of its original value. Okay. So let us have an expression for the resistance. Here we know capital R is equal to rho L by A. Now this is our initial value of resistance with the length L and area cross section capital A. Okay. Now if it is length is increased to the new length, let us take this, that is L1, and the new area cross section is A1. So in that case, let us denoted by R1, that is the new resistance. R1 is equal to the resistivity of the material that remains the same, and L1 is the new length and A1 is the area cross section. Now what is L1? L1 is equal to, it is stretched to 3 times original length, that is 3 times of L, and without any change in volume, the corresponding change in the area cross section, that is A1 is, it is reduced to 1/3 of its original area cross section. So A1 is equal to 1/3 of the original area cross section. So let us substitute, that is R1 is equal to rho into L1, that is 3 times of L, divided by A1, that is 1/3 of A. So that is equal to 3 is only there, this A by 3, the numerator, that 3 also come to the numerator, then the remaining things are rho L by A, that is 9 rho L by A. What is rho L by A? Rho L by A is the original resistance. So let us write 9 into 9 into the original resistance. That means the new resistance is the 9 times the original resistance. The next one, a constant wire of length 1 meter and diameter 0.71 millimeter has a resistance 1.2 ohm. Calculate the resistivity of constantine. First we can write the expression for the resistivity, that is rho is equal to R, the rho is equal to R A, that here wire, so R pi R square divided by L. So what are the values given? Here the resistance R is equal to 1.2 ohm, and the radius, instead of radius we are given the diameter, So that is d by 2 is equal to 0.71 by 2, that is equal to 0.355 millimeter. That we can express 3.55 into 10 raised to negative 4 meter. And the length of the constant in wire L is equal to 1 meter. So let us substitute in the equation. Rho is equal to 1.2 ohm, that is pi r square 3.14 into 3.55 into 10 raised to negative 4 whole square divided by 1 meter 1. Okay. So after the calculation, you will obtain the value of the resistivity of the constant in wire is 47.48 into 10 raised to negative 8 ohm meter. Now this is the value of the resistivity of the constant in wire. Now the next one, a silver wire of length 981.3 meter has a resistance 5 ohm. Determine the radius of the wire if the resistivity of the silver is 1.6 into 10 raised to negative 8 ohm meter. So here we are asked to find the radius of the wire. So first write the expression for resistivity. Rho is equal to R into pi r square by L. Therefore, the radius square is equal to rho L divided by R pi. Therefore, radius is equal to rho L divided by R pi all raised to 1 by 2. Okay. Now let us see what are the values given. Here, the resistivity of the silver is rho, that is 1.6 into 10 raised to negative 8 per ohm meter. And the length of the wire, that is 981.3 meter. And the value of the resistance, that is capital R, is equal to 5 ohm. So let us substitute all the values and calculate. So rho is equal to 1.6 into 10 raised to negative 8. Length is equal to 981.3 meter divided by resistance 5 ohm into 3.14 all raised to 1 by 2. Okay. Then after the calculation, you will get the value of radius is equal to 10 raised to negative 3 meter. That is nothing but that is equal to 1